So basically the project takes Athens as a case study site to explore the potential for experimental networks of evaporative cooling structures varying in height from 5 meters to 25 meters to provide a new commons, a new resource of cool and clean air to what are currently the polluted and heated streets of Athens. In the summer of 2024, we tested our first prototypes at the La Track skate bar in Athens, and we achieved cooling of 10 degrees Celsius within 15 minutes. I guess this project is responding in particular to a document which was produced by the municipality of Athens called the Athens Resilience Strategy for 2030. And in that, amongst other things, they called for the need for the city to provide guaranteed spaces of cool air given the very serious challenges which the city is going to be facing in the coming years.
The idea that nature can really play an incredibly important role in cooling our cities was something that came out very clearly in the Resilience Strategy 2030. And that was, it was kind of clear that Athens was one of the most densely built cities and densely populated. We had 16 point something thousand per square kilometer. I mean, Kypseli is one of the densest neighborhoods in Europe. So this creates, of course, conditions for more heat and more pollution. So what happens in these types of conditions is that we have a lot of heat absorbed by the different hard surfaces during the day and released during the night. And also we have a lot of heat that's being released into the atmosphere by cars and air conditioners. Is really a death trap for the people. And so we needed to figure out different ways of creating initiatives and designs that change this the outcomes of heating the city more, and rather figuring out solutions for creating coolness in our city so that our city becomes more livable.
Athens is basically facing existential threats in the near future from heat and pollution. In practically any future scenario study that you do for the city, there are two phenomena playing themselves out: the urban heat island effect, which comes from the thermal mass of the city, which is characterized by large amounts of exposed concrete. These basically heat up over the course of the summer, producing temperature differentials already of 7, 8, sometimes 10 degrees Celsius between the city and what that landscape would otherwise be. In addition, Athens also suffers from what's known as the urban pollution island effect, which is the build-up of pollutants close to street level. This is exacerbated by what's known as the temperature inversion phenomena, which traps hot polluted air down at street level. Both the urban heat island effect and the urban pollution island effect amplify each other, but in addition, they are both further amplified by climate change. And climate change for this region is causing further increases in general temperature, and more importantly, we're already starting to see, and it's predicted to both increase the intensity and the frequency of heat waves, which have the potential to take the city into basically non-livable conditions. Thinking about this project in terms of ecological semiotics basically is a way to take what are potentially quite technical framings of heat and pollution, and actually identifies that these actually have much more wide-ranging effects upon how the city works as a system and actually how humans experience the city as an extension of themselves. Now, for me, this project is one of two parallel research projects that I've been engaged in recent years. One around heat and pollution in Athens, but one which has been looking at the work of the cybernetic anthropologist Gregory Bateson and a particular framing that he gave to how we should think about ecological systems. And he suggested that all complex ecological systems such as forests or lakes, but also cities and human social systems are actually characterized, can be thought of as always mental systems, always cognitive systems in some ways, and which we're actually a part of. So for Bateson, he actually criticized Sigmund Freud, the psychologist, for only thinking about our unconscious as being our unconscious within our physical brains and our bodies. Bateson said actually our unconscious is much bigger than that. It's not only inside, it's actually our ecological environments really are our unconscious. And he suggested that if we drive our extended minds, that is to say our environments insane, through things such as heat and pollution, then we're actually slowly damaging ourselves as well. And he suggested a couple of ways in which we can start to understand our environments as eco-mental systems, and that is through understanding that air flows, chemicals, heat, not only has a quantitative aspect, but always has a qualitative semiotic aspect. And so one of the things that we're very much trying to do in this project is to think through the challenges in both of those terms.
We want Athens to be beautiful and vibrant, and we don't want the public spaces to empty out of people because nobody can walk in the streets. So we have to figure out how to bring more nature, but we also have to figure out how other types of solutions, maybe that have to do with shading, or maybe that have to do with moving the air around, or having to do with evaporation, bringing water elements more in the surface, or other kinds of more innovative solutions are really, really, really crucial for cities like Athens. So, this idea of the tower that creates movement of air and with a little bit of water and evaporation actually can create a totally different sense of comfort on the ground is something that I hear with great pleasure, and I'm very happy about it being tried out.
So in this research project, we're exploring the potential for evaporative cooling, that is to say zero energy water-based installations conceived as urban evaporative cooling, as a new kind of collective equipment that can provide both cooled and clean air to the streets of Athens, but which is actually a means for engaging in ecological dialogues with the eco-mental systems of the city.
So natural cooling or passive cooling is a form of cooling that doesn't require active system or energy. So in this sense, passive evaporative cooling comes from a physical phenomena that implies the evaporation of water. And in this process, specifically the water as a liquid changes state into vapor, so from liquid state to gaseous state. And this is also known as adiabatic cooling. It's a process that happens without additional energy added to the system or to the environment. And therefore, what we have is the latent, so-called latent heat that is extracted from the surrounding environment, the surrounding air, lowering its temperature. So essentially this is what passive evaporative cooling is.
we using evaporative cooling? Well, basically by reimagining both some old vernacular techniques as well as drawing upon new research in the field, some of it directly done by colleagues in this team. Last summer, in the summer of 2024, we tested some prototypes in Athens using downdraft evaporative cooling. The principles are very simple, essentially an enclosed volume of air within a fabric tower is cooled through the misting of water at the top of the tower. The water mist evaporates, taking heat out of the air. The air starts to drop. We generated last summer a temperature drop of around 10 degrees Celsius with a pleasant breeze. Okay, slowly falling. So you've got the temperature slowly falling and the humidity slowly rising, as you'd expect.
It looked interesting and it worked, and I think people were really engaged by it and curious about it. I think it also helped that we did communicate it a bit, like what it was and what it did. But I don't think it could have gone better than it did in terms of like how people responded to it. Like we left it up for longer and it worked, and everyone was curious about it, so I think it accomplished its mission in just about every way.
Following from the tests we did last summer, we're now planning a series of further iterations over the next 3 years, testing towers at the smaller size at around 5 to 7 meters high, again at La Traque, but also at some other partner sites, but also to test some much larger structures around 25 meters high. These we're conceiving as very much a kind of open-ended design research experiment. So how we work together with local manufacturers and local skill sets, both around fabrics, but also structural fabrication, is important. And colleagues Flora and Aaron have been doing work exploring different ways in which we might test different structural solutions, but also deploy different kinds of fabric possibilities. Importantly, the 25-meter high towers have the potential not only to cool large amounts of air, but also to draw down air from above the worst pollution levels in Athens, which we know is situated close to ground level, close to street level, often held in place by the temperature inversion phenomena.
What we wanted to do was something that's a little more accessible in terms of the type of structure and the type of sort of fabrication that you'd need. And I think through the conversations we had, that we identified two different scales. There was a scale that works in a citywide scale that might sit in a public square and might be sort of 30 meters plus high. And then there was this more of a domestic scale where it would sit in someone's courtyard or on someone's roof terrace to generate some sort of local cooling. And I think for both of them, it was a question of doing enough sort of development work to establish the feasibility in terms of the cost. Because clearly, if these things are sort of crazy expensive, it's going to limit the opportunity. So the goal has got to be to make it as accessible and affordable as possible, particularly the small scale ones.
And looking at the drawings that you sent of the sort of desired, quite feminine form in a way of the tower would take on, and then I found a Paco Rabanne dress, similar, these sort of faceted, they often would be squares, but could easily be triangles.
So I think what we're now interested, particularly again for the smaller, sort of more domestic things, is trying to find a way that people can source the materials locally themselves, and it's things they're familiar with. So, using a few bamboo poles, or maybe it could be sort of timber from your local sort of merchant, and then with the development with the fabrics that Flora's been doing at the RCA. Again, these things are things that anybody can source and sort of assemble themselves, you know, keeping it as lightweight as possible, so that you don't need expensive equipment to assemble these things. It can be done by a couple of people.
But the idea that, you know, we could have arteries, you know, knitted in a circular manner to create this superstructure that essentially could be covered with yarn, which is canvas, and that becomes the membrane without having to have the membrane. But then we did all sorts of other experiments with the denim, and we coated it in a thermochromatic ink, so, you know, people could visibly see the colour change.
We wanted to test the hypothesis in which the tall towers, when strategically placed or located across the urban layout, we can not only deliver significant volumes of cold air on the surroundings, but also bring down clean air to mitigate pollution levels in Athens. The polluted air remains at lower levels underneath the air canopy, which usually sits over the Athenian basin. And this is a really interesting landscape in which 3 mountain ranges are surrounding the city, defining some sort of an oval-shaped lowland where the city stands. And this creates a temperature inversion phenomena, a volume of warm and polluted air trap at pedestrian level. And the interesting thing of this is for us to know how the air moves in between buildings, and this is for us an opportunity by using these computational tools to understand what is still unknown precisely, which is how the air moves in between buildings and how the towers and the downdraft of air movement that we are creating with them could significantly impact the air distribution and air movement.
We imagine the communities or the user groups that might test these towers have different characters. So the smaller towers, we want to develop solutions which could be positioned permanently in some situations, or can be easily mounted and dismounted by 1 or 2 people. The larger towers have a different potentiality. They might be adopted by key stakeholders in the city who have ownership of key parts of urban space. But importantly, they might be deployed by the municipality as an emergency infrastructure which gets deployed in public spaces during extreme heatwave events. The larger towers, and in particular if we have a small network of them in certain areas, actually provide, according to the computational fluid dynamics models, would provide clean and cooled air, not just to their very immediate surroundings, but actually the models suggest to entire neighborhoods. One model suggested that 4 of the 25-meter high towers would actually provide cooler and cleaner air to several square kilometers. So one of the interesting reasons for taking on this ecological semiotics approach becomes particularly clear when we look at pollution, because actually when we examine the polluted airs of Athens, it's full of particles, and those particles have very different stories to tell, which give us a very clear idea and sense of the extended body of Athena and the troubled eco-mental systems of Athena. So the particles in the air include, for example, dust, which is frequently brought over from the increasing desertification of the Sahara and Sahel regions in Africa. This dust is increasingly polluted with toxins from industry and wars in the region. We're seeing more locally, climate change has meant that forest fires in the local region are becoming more frequent and more intense. This means frequently Athens is covered in smoke from local fires, which has then the double effect of also removing the lungs of Athena. 3 years ago, the fires on Evia were allowed to burn themselves out, reducing huge amounts of air cleaning forest. And actually these processes then intensify as the removal of the forests removes the ways in which forests help to produce rain, thereby increasing the likelihood of further fires. Then as we move into the city more closely, the intense motor vehicle traffic produces the usual range of pollutants from that. And then fuel poverty in significant parts of the Athenian population means that wood and other rubbish is burnt for heating in the winter, but even just for cooking in the summer. So we have this complicated mix of particles that have very different stories to tell. And part of the project here is yes, establishing these routes for dialogue so that the cooling devices themselves also become pollution monitoring devices. But we also imagine a parallel project of citizen science engagements with local communities, for example, working with schools to build pollution sensors that can then be taken to the houses and flats and balconies of Athens to try to give us a better idea of how these airs and particles are moving around, and to try to establish both a greater local awareness of this, ways in which people can protect themselves from it, but also to establish the potential for bigger solidarities to emerge between Athens, the regions around Athens, but even with the desertification in areas of Africa and so on. That this is one extended ecological system. Obviously, no amount of evaporative cooling towers can solve these problems. These are very large, significant problems that Athens and cities around the world are facing. However, these kinds of devices can help, and they can help local communities and municipalities manage some of the dangers. But they also have other possibilities, which is to help to establish a greater understanding of how the ecologies of the city are working, and to build up an increased ecological sensitivity, or an ecological aesthetics, we might say, around our sensitivities to heat and pollution. And one of the wider, if you like, semiotic or building our bodily sensitivities, one of the roles that these kinds of projects can play is trying to build up a greater social awareness of what we're talking about when we talk about wet bulb temperatures and dry bulb temperatures and relative humidity and what that feels like, because that's actually a set of skills that we're all going to need to learn in the future. And importantly, this is a significantly publicly funded project, and that shapes, again, our methods away from trying to design a air cooling commodity or thinking about it as some kind of technological solution, but is rather helping to describe a wider project or a wider set of problems. And we're seeing the deliverables of this as primarily open source material. So we'll be producing a series of collective commons guidelines so that people can conduct their own experiments. And we'll be developing a kit of parts for people to potentially use in their own experiments. For these reasons, what we're calling the social form of the technology becomes a very important question for us. The environmental activists have long argued, for example, that a wind farm owned by a multinational energy company should not be thought of as a green or sustainable technology. That actually there's nothing fundamentally wrong with wind farms, but a permaculture experiment having a small wind farm is one thing, an energy company having setting up extractive relationships across large landscapes is something very different. And in fact, many of our allies in Athens are actually involved in protests against some highly problematic, highly unecological wind farm projects that are happening across Greece. So the social forms that technologies take, the ways in which they enfold energetic, material, social flows and relations of all kinds, speaks directly to how we think about cities and ecologies as eco-mental systems. And this addresses directly the curator's call for architectural and design research into intelligences of all kinds, social, natural and artificial. And so this project, therefore, is not simply a research project into evaporative cooling, but it's a research project into the potential social forms of evaporative cooling.